Imagine a new gold rush, not in California nor the Klondike. This time, the frontier is space, vast, dark, and glittering with unimaginable wealth. We're talking about asteroids. Some are laden with platinum, others with iron and nickel. These are not just rocks, they are cosmic treasure chests waiting to be unlocked. This is the future calling to us. Think about the moon, for so long a silent, dusty companion. Now we see it differently. It holds water ice, hidden in its shadowed craters. In space, water is more precious than gold. It means life, it means fuel. The moon could become a vital outpost, a stepping stone to the stars. Human ambition is shifting, we have explored our world. Now our gaze is fixed firmly on the heavens. The final frontier is no longer just for observation. The cosmic lottery awaits. Our home, planet Earth, is generous. It has provided for us for millennia, but its resources are not infinite. Think about your phone, your computer, the car you drive. They all come from materials dug from the ground. We live in a closed system. What we have is what we have, and we are using it up rather quickly. The demand for these materials is growing every single day. More people are born, more nations develop, technology advances at lightning speed. All of this requires resources, especially rare earth elements. These are vital for our green technologies, for our digital world. Our appetite seems insatiable. Now look up. Space offers an answer. A vast, almost incomprehensible reservoir of materials. Asteroids, trillions of them, orbit our sun. Many are rich in the very elements we need. The solar system is a giant pantry. We just need to figure out how to reach them. The universe is not empty, it is filled with wonders and with resources. Different celestial bodies hold different kinds of treasures. Not all space rocks are created equal. Some are dusty, some are icy, some are metallic. Understanding this variety is the first step. It is like learning the cosmic A, B, C's. Let us consider asteroids. These are remnants from the birth of our solar system. They come in various types. C-type asteroids are carbon-rich. They might hold water and organic compounds. S-types are stony. M-types are metallic. These M-types are particularly interesting. They can be packed with platinum group metals, metals that are rare and valuable on Earth. Then there are the rare earth elements. You might not hear about them every day, but they are in your gadgets, your electric car batteries, your wind turbines. They are the unsung heroes of modern technology. On Earth, their supply is limited. Space could offer new, abundant sources. Imagine that kind of technological freedom. Let's delve deeper into M-type asteroids. These are the real cosmic jackpots. Imagine a celestial body made mostly of metal, iron, nickel, cobalt, and laced with precious metals, platinum, palladium, rhodium, iridium, osmium, and even gold. These are not just trace amounts. Some asteroids could be incredibly rich, solid chunks of treasure floating in space. The potential value is astonishing, truly mind-boggling. A single, modest-sized metallic asteroid could contain more platinum than has ever been mined in human history. Think about that. One asteroid. It could revolutionize our access to these critical materials. The economic impact would be immense. It could shift global markets. It could fund entirely new industries. How do we find these cosmic gold mines? We use telescopes. Powerful ones. We study the light reflected from asteroids. This is called spectroscopy. It tells us what they are made of. We are already cataloging them, mapping their orbits. It is like prospecting from millions of miles away. We are cosmic detectives, searching for clues. The challenge is part of the allure. Section 5. Lunar oases and Martian prospects, fueling our future. Now let us turn our attention closer to home, to our moon. For decades, we thought of it as barren, but we were wrong. There is water ice, lots of it, hidden in craters near the lunar poles. These craters are permanently shadowed, so the ice never melts. This discovery is a game-changer for future lunar exploration, and beyond. This lunar water is incredibly valuable, not just for drinking or for growing plants in a future moon base. We can split it using electrolysis powered by solar energy into hydrogen and oxygen. What do you get when you combine hydrogen and oxygen? Rocket fuel. Powerful, efficient rocket fuel. The moon could become a refueling station, a galactic pit stop for missions to Mars and deeper into the solar system. And what about Mars? The red planet also holds promise. We know there are various minerals in its soil. It's regolith. This Martian dirt could be used for construction, perhaps using 3D printing technology to build habitats, or to extract useful elements. It is less about exporting back to Earth and more about using resources on site. Space mining makes this possible. Section 6. The grand challenge: engineering our cosmic ambitions. Embarking on space mining is no small feat. The engineering challenges are enormous, truly monumental. Space is an unforgiving environment. Think about the extreme temperatures, swings from boiling hot to freezing cold, and the vacuum of space. It is not a friendly place for machines, or for humans for that matter. We need robust technology. Then there is radiation. The sun bombards us with particles, and cosmic rays zip through space. On Earth, our atmosphere and magnetic field protect us. In space, there is little protection. This radiation can damage sensitive electronics. It is a serious health risk for astronauts. Shielding is essential, but shielding is heavy, and heavy things are expensive to launch. Robots will be our brave pioneers. Consider mining in zero-gravity or microgravity on a small asteroid. How do you drill into a rock that is not anchored? How do you collect the fragments? They will just float away. We need entirely new mining techniques, tools and processes designed for these weird conditions. Imagine a vacuum cleaner but for space rocks. It is a whole new kind of engineering. Section 7: Stellar Stewardship, Navigating the Ethics of the Void. As we reach for the stars, we must also look within. Who owns the resources in space? This is a big question. The Outer Space Treaty of 1967 is a starting point. It says nations cannot claim sovereignty over celestial bodies. No country can own the moon or an asteroid. But what about private companies? Can they extract and own resources? The legal framework is still evolving. We have a chance to do things differently, to avoid repeating the mistakes we made on Earth. Here, resource extraction has often led to environmental damage, to conflict, to exploitation. Do we want a Wild West in space? Or can we establish sustainable practices from the start, a sort of leave-no-trace philosophy for the cosmos? It is a vital consideration. International cooperation will be key. The benefits of space mining could be immense for all of humanity, not just for one nation or a handful of powerful corporations. Section 8: Forging a New Destiny: Space Mining and Humanity's Cosmic Age. Space mining is more than just digging for metals. It is a cornerstone for humanity's long-term future in space. It provides the raw materials to build permanent habitats on the moon, to establish colonies on Mars, to construct large space stations. Imagine cities in orbit, powered by the sun, built from asteroid materials. This is the vision. This endeavor can also help our home planet. By moving heavy industry off Earth, industries that are resource-intensive or polluting, we could shift them into space, where energy is abundant from the sun and raw materials are plentiful. This could allow Earth's environment to recover, to heal. Imagine a greener Earth, sustained by a bustling solar system economy. We are on the cusp of creating a true space-based economy. Manufacturing in zero gravity allows for unique materials. Solar power satellites could beam clean energy down to Earth. Asteroid resources could fuel a new wave of technological innovation. Humanity could become a multi-planet species, our future no longer confined to a single, fragile world. This is a profound shift. So, the quest for space resources is about much more than wealth. It is about knowledge, about exploration, about pushing the boundaries of what is possible. It is about securing a grand and hopeful future for humankind among the stars. The universe beckons, and we, with our ingenuity and ambition, are beginning to answer its call.